In this learning objective, we're going to keep getting familiar with having an angle in radians, and we're going to talk about identifying quadrants. All right, so if we look at our xy plane, we have our y-axis going up, our x-axis going to the left and right. You can see it kind of gets broken up into 4 sections, all right, just like a 4-square court. And we're just going to number them. All right, we're going to do a start in the top right, and we're going to call that quadrant 1. For some reason, whenever I write the quadrants, I always do them in Roman numerals. I think that's the way I learned it. Or you could just put normal 1 if you wanted to. All right, and then another thing in math, a lot of times when we are rotating, we always go counterclockwise, just like we did with our angles in standard position in the previous learning objective. So we're going to go counterclockwise, means this one's 2, this one's quadrant 3, and this one's quadrant 4. All right, so those are our 4 quadrants. All right, top right is quadrant 1, and you rotate counterclockwise from there. One thing that's going to be really important going forward is knowing which quadrant is the terminal side of our angle, because it'll end up being important for what we're going to learn in our next learning objective. And now we're going to make that tradition to only working in radians. All right, if you want to do this in degrees, that'll be covered in the bonus objectives. All right, but part of this whole unit is getting comfortable with radians and using radians. All right, so before we begin, a couple things to remember. If I have my xy plane, at the 0 angle is there because I haven't moved it all. If I go all the way around and do a full revolution, that is my 2 pi angle in radians. Half of the circle going just to the left is pi radians. All right, so those are things we learned in our last learning objective. Some other things that'll be helpful is if I only go a quarter of a circle, if I go to here, I've done half of a half circle. So I'm going to divide pi by 2, and this is pi over 2. All right, so 90 degrees is the same as pi over 2 radians. And going straight down actually ends up being 3 pi over 2. All right, so those are they're called quadrantal angles because they break up the quadrants. All right, but those are the important angles we're going to have to know for this learning objective. All right, so if we want to find the quadrant of 5 pi over 6, again, I'm going to draw what I just had on the last slide real quick. 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, so those are kind of the cutoff points for the angles. All right, so there's a bunch of different ways you could do this. So I'm going to show one way in this example, and I'll show another way in the next example. So the way I would do it, or one way you could do it, is I'm looking at 5 pi over 6, and the bottom of this fraction is 6. So to compare it to other things, I want to compare it to fractions that are also over 6. So you can do that with pi over 2. Pi over 2, if I multiply the top and bottom by 3, I get 3 pi over 6. Pi, top and bottom by 6, I get 6 pi over 6. 3 pi over 2, I multiply by 3 again, I get 9 pi over 6. And 2 pi is going to be 12 pi over 6. So now I can easily compare these things so they all have the same denominator. And now I look at the number here. I have 5 pi's over 6. All right, this one I have 3 pi's over 6. Here I have 6 pi's over 6, 9 pi's over 6. And where's 5 going to be in comparison? 5 is between 3 and 6. So my angle is going to be somewhere over there. So my final answer is going to be quadrant 2. All right, so by just comparing it to the other angles we know that break up the quadrants, I have to make them the same in the denominator, and then I can figure out what quadrant I'm in. Well, here's another way you can do it. So 7 pi over 4. Okay, let me draw our important angles. All right, so here's the other way you can do it, and this is kind of the way you can do it for any angle, is pi over 2 is the same as 0.5 pi. Pi is the same as 1 pi. 3 pi over 2 is 1.5 pi. I'm just changing the fraction, and this is 2 pi, obviously. Okay. So we can almost kind of ignore the pi part a little bit, and if we just look at the number that accompanies it, 0.5, 1, 1.5, and 2, we can compare that to our actual angle. So for our actual angle, if we kind of ignore the pi part, 7 over 4 is equal to, just using a calculator, 7 divided by 4 is 1.75. So I have 1.75 pi's, and where does 1.75 fall in 0.5 pi? It's more than that. It's more than 1 pi. It's more than 1.5 pi, but it's less than 2 pi, so it has to end up in this quadrant here. So the answer is quadrant 4. All right, so I could use a decimal approximation for the non-pi part and then compare that to the other parts I know to get my approximation. All right, so here's one for you to try on your own. Again, there's 2 different ways to do it. All right, what quadrant is 2 pi over 3 located? And for this one, you should get quadrant 2. All right, 2/3, the non-pi part is 0.66, and that's between 0.5 and 1, so we end up in quadrant 2. All right, so one of the things we mentioned when we were talking about angles in standard position is you can make angles that are bigger than 360 degrees or bigger than 2 pi. All right, you can start with your angle and rotate all the way around multiple times and end up with these really big angles. They still look like a small angle if you kind of erase that red swirl, all right, but I've rotated around to create a bigger angle. All right, so how can we work with these bigger angles? There's a few different ways, so I'll show you 2 different ways in the examples. The first way is kind of doing the same thing we did previously, is kind of ignoring the pi part and just looking at the fraction part. So 13 over 6 is 2.166. And if I compare that to my circle, I'm just using the decimal versions for these comparisons, I'll see that the number of pi's I have is more than 2, so it's more than the full circle. All right, but it's not an extra 0.5. So we know every single time we go kind of this one quadrant, I get a 0.5 added to my number of pi's. So the next thing going around will be 2.5. And 2.16 is bigger than 2, but it's less than 2.5, so it had to end up here. The final answer is quadrant 1. All right, so I'm just using kind of the fact that every time I go another 90 degrees, I go another 0.5 radians, and that can help me figure that out. However, where that stops working for me in general is once you get these angles that are really big, because then you're kind of adding all these 0.5s over and over again. All right, so the easier way I think about it is if we look at our angles again, now we have this angle that could rotate around a lot, like that. But if you kind of, again, get rid of that red spiral, that angle looks the same as just an angle that rotated that way. So what I can do is just kind of get rid of all the extra rotations and look at a smaller angle. So we're going to start off the same thing. I'm going to look at 27 over 4. 27 divided by 4 is 6.75. So this is 6.75 pi. But every single time I want to get rid of one of these revolutions, if I want to kind of get rid of this part here, you can see that little arc I just made in blue is a full circle. So what I can do is I can subtract a full circle, which is 2 pi, and that gives me 4.75 pi. Right, so 4.75 pi would be that angle there, which is the same angle I'm talking about. And I can do this again, subtract off another 4 revolution. So I'm going to subtract off another 2 pi. That gives me 2.75 pi. I'm just going to keep doing this until I get an angle that is smaller than 2 pi. So I get 0.75 pi. All right, and this is the angle I want to discuss now because that's actually a number smaller than 2. So it's in our normal 0 to 2 pi range. And now I know where is 0.75 pi. It's between 0.5 and 1. It's going to be over here. So this one is in quadrant 2. All right, so this angle that I drew at the beginning is not the actual angle, but I was just using it as a reference. The actual angle ends up being in quadrant 2. All right, so here's one for you to try on your own. Go ahead and figure out the quadrant for 10 pi over 3. And the answer you should get is that it's in quadrant 3. All right, 10 over 3 is 3.33 pi. That number is bigger than 2, so I'm going to subtract 2 off of it, and it's the same as 1.33 pi. And 1.33 is more than 1 pi and less than 1.5 pi, so it ends up in quadrant 3. All right, and another thing that we learned with our angles in standard position is that you can have negative angles. So negative angles means you're just going to rotate the clockwise direction. All right, so this would be a negative angle. So how we're going to work with them? Well, I could just add 2 pi to this angle and get back to the same place, but now I'm going to have a positive angle. So just like we just did in the previous example, so we subtracted 2 pi to get 2 smaller angles, here we can just add 2 pi. All right, so negative 7 pi over 6 If I do 7 divided by 6, this is negative 1.166 pi. That's a negative thing, so I'm going to add 2 pi to it to make it a nice positive angle. So if I add 2 to that number, I get 0.833 pi. All right, so that's a nice positive one, and then 0.88 is between 0.5 and 1, so this is in quadrant 2. All right, so just like we were doing the previous one, we're just adding 2 pi to get to a nicer angle that we can reference. All right, negative 7 pi over 3 is negative 2.33 pi. I'm going to add 2 to it, get negative 0.33 pi. In this case, that's not enough because it's still negative, so I'm going to add another 2 pi to it. And that gives me 1.667 pi. And now that it's a positive number, I know 1.66 is between 1.5 and 2, so that puts it in quadrant 4. All right, so very similar to the other ones. In this case, adding it so you get a positive angle, and then comparing it to your kind of quadrant angles that we know before. All right, so here's one for you to try on your own. All right, what quadrant is negative pi over 4? And in this case, you get it's in quadrant 4. So negative pi over 4, you just rotated down like that, and that's in quadrant 4. All right, so this learning objective, you're going to do a skill check. All right, the skill check's going to have 4 problems on it. All right, you're going to have 4 problems where you define what quadrant it's in. At least one is going to be a number where it's bigger than 2 pi. You just subtract 2 pi to get to a smaller angle. And one's going to be negative, where you have to add 2 pi to get to a positive angle. All right, but if you can do all the problems in this video or on the practice sheet, you'll be able to do the skill check.